Yeah, so then we'll be looking at the topic, the half-cell equation. So it is quite advisable that you should have watched the video on oxidation number and redox reaction. So if you haven't watched them, I will drop them in the description box. So, however, let's move on. So redox reaction is simply means a reaction that contains reduction and oxidation at the same time. So there are two ways by which a redox reactions can be. A redox reaction can be a simple equation, so and a redox reaction can be a complex equation. So let's look at it. What's the meaning of simple equation? What's the meaning of a complex equation? Example of a simple equation is a type of equation, for example, a zinc reacting with maybe a chlorine to produce maybe Cl2 plus zinc 2 plus. Now you see this type of reaction is a simple reaction. Why? It's because it requires a one you can see it is not a it's a reaction that is a reaction between atoms and molecules. Let me put it that way. So because it does not require a compound, one example of a complex reaction is something like this. Now this type of reaction is simply it is simply a complex reaction, because why? In this reaction we have a compound. So a complex reaction requires the presence of a compound, while a simple reaction just require an atom or a molecules. So a molecules, if I say chlorine molecules, hydrogen molecules, so this is what I meant. So in a simple reaction we only have the zinc chlorine atom, chlorine molecules, and the zinc ion. So I hope it's clear to you. But in the compound one, we can have this. We can even have something like C2O4 to minus plus Cr2O7 to minus. You understand? Like to give something like CO2 plus Cr3 plus. Now this type of reaction, it requires a complex equation. So a complex equation is a type of equation in which there is the presence of a compound, but in a simple one, there is no presence of any compound. I hope that is clear to you. Now, so we want to start with a simple one, and so the simple equation is where we are starting from. So for the simple equation, every simple equation can be balanced in a simple way, and that is called the half-cell equation. So at the end of the day, every student are meant to know how to balance in a simple way. So let's use an example. Let's look at a particular example. So example 1, so that we can understand how to balance using half-cell equation. So let's say we have sodium plus sodium solid plus hydrogen ion to give sodium plus H2 hydrogen gas. So these occur in aqueous, these aqueous. So this is gas solution. Now note this, that a redox reaction is not meant to be balanced stoichiometrically. What do I mean by stoichiometrical? Imagine this particular set of questions is given to a student to solve. Some student will have thought that, okay, sodium plus hydrogen ion, and to give sodium plus H2. Normally one would have thought that, okay, because hydrogen is 2 here, so because hydrogen is 2 here, then 2 here, so it means that here we have one sodium, 2 hydrogen, that this equation is balanced. This is not balanced. It's because in redox reaction we do not just look at this stoichiometrically. Redox focus our attentions both on the stoichiometrical of it, and also it also focuses on the ion and electron. Now if we are to look at it, the oxidation number of sodium here is 0, plus oxidation number of hydrogen is +1, times 2, that's 2. So the total electron in the left hand side or the reactant side is 2. But here is 1 times 1, that is sodium is 1, so 1 times 1 in front of it, so that is, there is a 1 here, so 1 times 1, that is 1. So hydrogen is 0, and at the end of the day we have 2, we have 1. So this equation is not balanced. So this is the reason why it's not balanced, is because the transfer of electron is not balanced. But looking at the atom is balanced. So redox, a redox reaction is said to be balanced if the number of electrons in the left hand side is equal to the number of electrons in the right hand side. So this type of reaction, like I said, we are meant to balance it using half cell equation. And the reason why we're using half cell equation is because it is a simple equation. It is a simple equation, and simple equation means to be balanced using half cell equation. Now, so let's look at it. So the first thing you're going to do is to break it out into two. So for the reactant side become this, and this become this. So you break it out, that is sodium become Na plus. So this is equation 1, but you need to identify it. So okay, let me put it in the right way so as to portray out a good illustration. So now from here we have sodium, so to give Na plus. So look at it, the oxidation number of sodium is here is 0, but here is 1. That is increase in oxidation number. So what is that? That is oxidation. So we call this oxidation half. So this is our oxidation half, and this is our equation 1. So we move on. We have H plus reacting to give what? H2. Oxidation number flow from +1 to 0, and +1 to 0, that is reduction. So that is reducing oxidation number. So reduction half, and we call this equation 2. Now if you are solving this for any standard examination, just know that automatically this side receives 1 mark and this side receives another 1 mark. So because they will mark you for it. Now however, the next one now is to show the mechanism of what happened. That's the next step, to show the mechanism of what happened. Now look at it. For sodium, for any element to be positive, it simply means that the element has lost electron. So for sodium to have carried 1 electron, sodium at the beginning is neutral, it does not lose any electron. But however, it carries positive. It shows that +1, it shows that sodium has lost 1 electron. So minus sodium lost means negative, lost 1 electron. Can you see that? So now I will call this equation 3. So because this is 2 already, this is 1. So then from there, the next one is hydrogen. So hydrogen plus. Now always erase the mentality of 2 molecules or atomicity. Focus on 1, okay? Focus on 1, understand 1. So this is how you're going to do it for beginners. So always go like this. So you will think of it that for H plus to become, this arrow means become, for H plus to result to hydrogen, here it means that H plus has lost 1, but here it's gained the 1 back. So it means at the end of the day, it's gained the 1 back. So it's gained the 1 back, but however, the question says 2. So if this one is 2, then this one will be 2, then this one will be 2. Okay, I repeat again. So I said that the question talks about hydrogen ion becoming what? H2. But I said not to confuse yourself, always go for, first think about it, what if it is 1. So hydrogen ion become hydrogen. So it means that it has gained 1 electron. So when it gain 1 electron back, it become one hydrogen. So now, because hydrogen carrying positive means that hydrogen has lost 1 electron. So if it is carrying 2, it means it has lost 2 electrons. So if it has lost 2 electrons and it's gained 1 electron, it will become 1 plus. So 1 plus, if you add the electron to it will become normal hydrogen. Do you see it? So when an element loses electron, it becomes partially positive. So the same thing here too. The hydrogen, so here, so in the H plus, the hydrogen has lost 1 electron. So for hydrogen to have become this, it means that the hydrogen gained the 1 electron back. But the question demanded, according to the equation, demanded for 2 of it, then this place is 2, then 2 of the electrons will be required. So it means that 2 ion of hydrogen require 2 electrons to give 2 of hydrogen. So this is equation 4. Now once you show the mechanism of the 2 electron, then the next thing to do is to multiply both sides. So you have to check both sides. If the number of, look at the sign, if they occur at the same side, the sign has to be different. But if they are occurring at different side, the sign has to be the same. I hope that is clear to you. Now let's move on. Now the total electron here is 2, so I will multiply the whole of this equation 3 by 2 so as to balance it. The total number of electrons here is 1, so I'll multiply all this by 1. So you can see what I did here. So the number of electrons here to multiply here, and the number of electrons here to multiply the up. So that is how it is done. So at the end of the day, 2 times sodium will give you 2 sodium So 2 times electron will give you 2 electron, and 2 times sodium ion will give you 2 sodium ion. Then 1 times 2H will give you 2H plus. So 1 times 2 electron will give you plus 2 electron, and 1 times H2 will give you H2. Now, so the next thing that remains is to add the two equations together. So now, before that, look at anything that can be cut. So minus, we cancel this. So this, we cancel this. Now look at it. If it is the same sign, it can cancel itself. Because at the end of the day, we are adding reactant to reactant, product to product. So minus 2 plus 2, that will give you 0. So that's the reason why I cut it off. And that's the reason why it has to be different sign. Now from here, so I have 2 sodium plus, 2 sodium atom, 2 sodium atom plus 2 hydrogen what ion to give 2 sodium positive plus hydrogen gas. Now this is the overall equation, so let's confirm if it is correct. Now from here, sodium is standing alone, 0 0 times 2, that's 0, plus hydrogen is plus 1 times 2 plus 2. Now here 2 times sodium, that's 2 times 1, sodium is coming plus 1, 2 times 1, that's 2, hydrogen is 0. So at the end of the day, you can see that the right hand side is equal to the left hand side. So this is what we call redox reaction. So redox reaction balance the ion, and it balances stoichiometrically. If you have to look at it, 2 of sodium, 2 of sodium, 2 of hydrogen, 2 of hydrogen. So unlike the first one, that in which it only balances the stoichiometry or the mole of it, but does not balance the ion. So redox must be able to counter both stoichiometrically and in other form. I hope that is clear to you. So now there are many examples as well that can also be formed from this idea or mentality, but the greatest of it is that you need to understand the fact that in half cell equation, all you have to do is to split the equation into 2 halves. Now let's look at another one so that you can understand better which should be the last example under this aspect. Now let's say we have Fe2 plus Br square, that's bromine gas, and Fe3 plus Br minus. Now solution, the first thing you're going to do here is that you are going to break it into 2 half equation. Don't forget, one will be reduction, one will be oxidation. So for Fe2 plus to have become Fe3 plus, the best way is to just look at the valency. So from plus 2 to plus 3, that is increase in oxidation number, right? So you write it down. So from plus 2 to plus 3, from plus 2 to plus what? 3. So that is increase. So from plus 2, how do I get the 2 here? How do I get it here? So from plus 2 to plus 3, that is increase in oxidation number, that is oxidation, and we call that equation 1. So Br2 to Br minus, so from 0 to minus 1, it reduces, that is reduction. The oxidation number reduce. So because bromine is carrying minus 1 and bromine gas is not carrying anything, so it's 0. So that is equation what? 2. Now once you have done that, then you now show the mechanism. You can see that's what we did here too. We first show it, we show your oxidation half, reduction are very important. I told you this 1 mark. Then you show the mechanism. After show the mechanism, you multiply both sides, you exchange the number of coefficient of the electron so as to balance and cancel the common terms. Now here, so we have Fe2 plus. For Fe2 plus to have become Fe3 plus. Now look at it. You know, when an element loses electron, it becomes positively charged. So the same thing happen here. So it shows that for ion 2 to become ion 3, it means that ion 2 lose 1 electron. So this guy is balanced now, so we call it equation 3. So for the bromine, I've told you that you should always show the mentality of 2. So first imagine if it is 1. So for bromine to have become bromine minus, it shows that bromine has gained electron. I've told you if a chemical species lose electron, it becomes positively charged. if it gain electron, it become negatively charged. So it means that bromine has gained electron. But the question says that Br2, because that's what the question demand. As you can see, Br2. So if the question needs 2 of it, then the electron needed to will be 2, and the number of bromine produced will be 2. So now it shows that we have gotten what we really needed here. To write this very well, so the sum of everything I said is that for the Br to have become Br minus, it shows that the Br gain 1 electron, because here is 1. Assuming it's 2 now, it will gain 2 electron. Assuming it's 3, it gain 3 electron. But the question says Br2, so the electron 2 will become 2, the Br2 will become 2. So once you have done that, then you now look at it. The number of the electron, is it equal? No. But notice what I told you, that the sign, if they're on the same side, I told you that the sign must be what? Different, which is correct. But if they're in opposite side, the sign must be the same. Now, so because the electron is not the same, so you will multiply both sides. So this one with this one. So 2 of this one, you use to multiply equation 1. 1 of the equation, can you see is 1? So 1 of the equation 1, you use to multiply the equation 2. So 2 times Fe will give you 2Fe2 plus minus 2 electron. We are doing this so that the number of the electron on both sides can be equal, and we can cancel them at the end of the day. So 1 times Br will give you Br2 plus 2 electron to give 2 Br minus. Then from here, so we move ahead. So the 2 we cancel this. At the end of the day, the next equation is now 2Fe 2 plus Br2, which is bromine gas, to give 2Fe 3 plus 2 Br minus. Now, so to find out, so this is the next equation, this is the final answer of the balancing, but we can confirm 2 times 2, 4. So bromine started alone, that is 0. So the answer here is 4. So let's see if it will equal to the right answer. 2 times 3, that is 6. But here is minus 1. So 2 times minus 1, minus 2. Then 6 minus 2, that is equal to 4. Can you see how balanced it is? So this is how to balance half-cell equation. And don't forget what I told you, half-cell equation can only be used for equations that require atom, molecules. So you can see here, you are not seeing something like BRO4 or something, because this is compound. The moment you are having something like this, it becomes a complex equation. So our next topic will be complex equation, how to balance redox.